Welcome back, kids. Algebra 1, solving quadratic equations without factoring all of our other methods that we're going to be using. And while I'm not going to show you all of them in this video, we are going to talk about all of them. So we're using the Beach Boys as our background music this time because I'm still in spring break mode. The weather's still nice here, so let's hope that continues, although I think it's supposed to get cold tomorrow, which, you know what, that just plain sucks. So let's stop thinking about that and throw ourselves into some math. All right, so what is a quadratic equation again? Well, remember what we're talking about here. We're talking about an equation that's in the form ax squared plus bx plus c equals 0, where it does not equal 0 because otherwise it wouldn't have a quadratic term and therefore would be a linear equation instead of a quadratic equation. This is standard form. Recall also that if I change that 0 to a y and make it ax squared plus bx plus c equals y, that becomes a function, something we can graph. So it becomes a quadratic function, which remember is a parabola. And remember when we graphed them on the calculator, you could see the parabolic shape. So how do we solve quadratic equations? So far, you have two methods. You have graphing and you have factoring. When we were graphing, you would take the quadratic equation and you would graph it with that y equals, and you would get a parabola and say this one, for example, had solutions 1 and 3. You would see those solutions or roots or zeros as x-intercepts on the graph. So the solutions, roots, and zeros are all the same thing. And on the graph, that's x-intercepts. With factoring, we use the zero product property, and you're going to want to go back and look at your previous video. Some of you did not watch that, so you may need to go back and watch that now. We have two other methods we're going to look at. We have finding square roots, which is only for quadratic equations that have no x terms, so we'll see that in a minute. Completing the square, which I will introduce the concept here, but I will teach the method in class. And then we have quadratic formula, which I will teach in this video. Let's start with solving a quadratic equation by finding square roots. So here's our original equation. 3x squared minus 75 equals 0. And please note there is no x term, or no linear term. Okay, no linear term here. And that's the key to these. You can't use this method if there's a linear term. Some of you were trying to solve the warm-up questions today by the previous class by just isolating and like you would in a regular equation, and you can't do that. But you can with this. Now take a look at what was done. So we write the original equation down. We isolate the x squared on one side of the equation. So they did that by adding 75 to each side and then dividing by 3 on each side. And you get x squared equals 25. Then we find the square root of each side and simplify. Here's the kicker though. When you find the square root of 25, you have to put this symbol in front of it. And this symbol has a name. It's called plus or minus. Plus or minus. And that is indicating that there are two answers coming out of that square root, both a positive and a negative 5. And that's because if I square a 5, I get 25. And if I square a negative 5, I also get 25. So we have two different solutions for that. Plus or minus 5, positive and negative 5. And you could also write it like so, with your curly braces, negative number, then positive number, numerical order being the key there. This only works, again, when there's no linear term. So let's go ahead and do a couple more examples of this type. Here we go. So we have first m squared minus 36 equals 0. So we're going to start off by isolating the m squared. So add 36 to each side of your equation. And you get m squared equals 36. Okay, let's clean that up a little bit. M squared equals 36. And then you're going to take the square root of each side. And remember that it's m equals plus or minus 6. So the two solutions for this one are negative 6 and positive 6. If I was to make this x squared minus 36 equals y, you would see that it crosses the x-axis at positive and negative 6. In fact, you probably wouldn't even see the vertex because it's all the way down at negative 36, but you would see on your calculator that it crosses at positive 6 and negative 6. Let's try the next one. Start off by, again, isolating that x squared term, so subtract 15 from each side. 3x squared equals negative 15. Divide by 3, Maybe you're already seeing an issue. I do. Take the square root of each side. And this is where your problem comes in. We can't do that. We can't do that, Miss LeCompte. We can't take the square root of a negative. This equation has no solution, but even that is not totally accurate. It's not that it has no solution. I'm going to go ahead and put a little word here. It has no real solution. When you get to Algebra 2 and you learn about complex numbers, you'll be able to solve that. You'll be able to solve that no problem. But right now, we don't have the tools. We haven't learned that concept yet. So in the real number system, that equation does not have a solution. If you were to look at the graph for it, so if you go up here, you go right up here and you change this 0 to a y instead and graph it, you'll see that it does not cross the x-axis. That parabola does not cross the x-axis. All right, next one. We're going to subtract 16 from each side. Oh, uh-oh, that gave me a 0 there. That's okay. We can divide 4 by 0. Excuse me. No, we can't. We can't divide anything by 0. I apologize. We can divide 0 by 4 and just get 0. And when you take the square root of 0, you just get 0. And we said we're supposed to have two solutions here, right? So we can't put plus or minus 0. This is what we call a double root. You're actually getting the solution 0 twice. We're getting that solution of 0 twice. So what's happening here is if I was to make this into something I could graph, I would have an equation that looks like this, where you cannot, you can see that it crosses at 0 at the origin, and you can't see two solutions because it's what's called a double root. This parabola only touches the x-axis once at 0. Okay, we'll look into that more in class. Let's move on and talk about what completing the square involves. In order to do that, we're going to talk about these perfect squares first. So remember what a perfect square is. Perfect square trinomial is when you square a sum or you square a difference. And remember what that means. That means we are foiling x plus y times x plus y. And that gives you that middle term of 2xy. So the pattern here is perfect square, perfect square. Perfect square at the front, perfect square at the back. 2 times the square root of the first and last term in the middle. Same thing here, except for the minus, because it's a difference in the product. So remember that, again, this means this, and write it all the way out. So what we're going to be doing is completing the square. Let's look at some examples here. To make a perfect square trinomial, you're going to halve b, that's a hard word to say, halve, halve, meaning cut in half b, and square it. That's the number that must be the constant in the expression to create a perfect square. And here's your formula. b divided by 2, the quantity squared. b divided by 2, the quantity squared. So what number completes each perfect square trinomial? That's the question here. Well, let's look. Our b value in the first one is 4. So we're going to take 4 divided by 2 squared. So 2 squared, or 4. And 4 is what would complete that perfect square. If that was a 4, I would be able to write that expression as x plus 2, the quantity squared. How about the next one? You do it. What did you get? 9. 9 replaces that double question mark, which would make this expression x plus 3, the quantity squared. Okay, what about the next one? This time we have a negative. Negative 8 divided by 2 is negative 4. Notice the use of parentheses. Okay, it's the biggest problem I have right now is students forgetting that there are parentheses there and it comes out positive. If I was then to have that as a 16, this would be x minus 4, the quantity squared. How about this one? Negative 1 squared is positive 1. And as a result, this would be x minus 1, the quantity squared. Now, you're not often going to use completing the square. It is kind of an extra skill compared to what we've learned and what we are learning this year. But it is important to understand the skill. I would say that when you do use it, you're not going to want to use it for a problem where the b value is odd. And I use this example here to show you why that is. Well, if I cut negative 5 in half, I get negative 2.5 or negative 2.5. If I then square that, I get positive 6.25. And we're not used to seeing decimals when we deal with quadratic equations. So probably we don't want to use completing the square for this one. It would make this one x minus 2.5, the quantity squared. So we'll learn the whole method of completing the square in class, but you are definitely responsible at this point for being able to recognize what value it is. We'll fill in those double question marks in order to make a perfect square trinomial. Use your formula, and no, you don't get that one on the sheet. You got to memorize it. Moving on. All right, quadratic formula, the moment you've all been waiting for. Here's our quadratic equation, A, B, and C, as before. And notice what we're doing here. We have a big formula, a whole bunch of symbols. Don't be upset by it. It's not that difficult. It's just a big order of operations problem. To solve the equation, you use the formula. X equals the opposite of B plus or minus the square root of the quantity B squared minus 4AC all over 2A. So if this was our example, A would be 2, B would be 3, and C would be negative 5. And you plug it all the way in. And then you do the math to simplify it down. So in this problem, we'd have negative 3 plus or minus square root of 3 squared is 9. 4 times 2 is 8 times negative 5 is negative 40. So 9 minus negative 40 all over 2 times 2. And if you simplify that down, you have negative 3 plus or minus the square root of 49 all over 4. So that's negative 3 plus or minus 7 all over 4. And now is when we go ahead and take out that plus or minus and do the math each way. One with the plus and one with the minus. The top one gives us 4 over 4, which is 1. The bottom one gives us negative 10 over 4, which is negative 5 halves. And that gives me my two solutions for this problem, which are negative 5 halves and 1. Now it's a perfect timing for a song to end because I have to do one more thing on this slide before I can go on to the next examples, and that is something I've done for the past couple of years. I have to sing you the quadratic formula, just like it said in the meme on the first page. I don't normally sing in videos, but let's just go ahead and do this anyway. Sorry about that. I just kind of thunked the iPad down onto the desk. Didn't mean to do that. I'm sure it was quite loud feedback in the video. You sing the quadratic formula to the tune of Pop Goes the Weasel. You ready? Here we go. Negative b plus or minus square root of b squared minus 4ac all over 2a. Yep, I just sang in your video, and hopefully that helps you remember it. The funny thing is, this one's actually on your formula sheet, so you don't have to memorize it. I do want you to know how to write it, no problem, because if you know it by heart, you'll make fewer mistakes with it. We're only going to look at a couple more examples for this, but I'm going to have to pick up this video later on in the day because it's lunchtime and it's time for me to go pick up my students. All right, so we only have a couple more examples to do. Of course, you can keep going, but I will be back to the video shortly. Okay, guys, so I'm recording the rest of this kind of on the fly. Sort of ran out of time here, and I'm supposed to be monitoring a different classroom at the same time, so I'm going to have to go ahead and get through this. So let's take a look at this example, and then we're going to do the one more at the bottom. And then we're going to stop for this video, okay? So this example gives us x squared minus 8 equals 2x. So we're going to solve this using the quadratic formula. First, you got to write that equation in standard form. In order to do that, that means we've got to take and subtract the 2x so that they're all on the left-hand side, equals 0. Now you're going to plug everything into your quadratic formula. Negative 2 is b, so the opposite of negative 2 is positive 2. Plus or minus square root of negative 2, notice the parentheses, squared, minus 4 times a is 1, and c is negative 8, all over 2 times a. So when you do the math out inside the radical sign, you got negative 2, the quantity squared is positive 4, minus 4 times 1 times negative 8 would be minus a negative 32, gives you 4 plus 32, gives you 36. Square root of 36 is 6, so you have 2 plus 6 over 2 and 2 minus 6 over 2. So you get either 4 or negative 2. Copy down this next one here, and then I want you to go ahead and do the math out for that one, and I'm going to go ahead and create another slide and do it out on the next slide. Okay, x squared minus 4x equals 21. Try it. Okay, x squared minus 4x equals 21. Get it into standard form by subtracting the 21. So x squared minus 4x minus 21 equals 0. Your a is 1, your b is negative 4, and your c is negative 21. So the opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So the opposite of negative 4 is 4 plus or minus square root of 16 minus 4 times negative 21 all over 2. 4 plus or minus square root of. Okay, 4 times 21 is 84. So 16 plus 84. See the minus negative there? Minus negative. Comes out to, is that 100, I think? 84 and 16, yep, 100. So far, we've only done problems where the radical ends up a whole number. And we're going to talk about this a little more. Why did I do that? We're going to talk about this a little more in class. This problem would probably have been done better by factoring rather than using the quadratic formula. But it does a good job of showing you what's going on. So there's 4 plus 10 over 2, and then 4 minus 10 would be negative 6 over 2 would be negative 3. So your solutions are negative 3 and 7. So that's all well and good, but we need to look at what happens when you don't have a nice happy whole number that's a perfect square to boot in that radical sign. So this is our last, I think I already said that the previous one was the last one, but I said we'd do one more. We're just going to set it up and then I'm going to stop because this video is getting a bit long. But this is a perfect example of why we use the quadratic formula. We're not going to have problems that always come out nicely like the previous two we looked at. Or actually 3, if you count, we did 3 examples of quadratic formula. This is a perfect example of a problem that we can use the quadratic formula for because of the decimals. So in the shot put, an athlete throws a metal ball through the air. Here is the parabola that defines that arc of the movement of that ball, where x is the horizontal distance away from the athlete and y is the vertical distance above the ground of that shot put. And so that parabola is going to be what we're going to use to solve this, and we're going to use the quadratic formula because of those decimals. So I want you guys to go ahead and set it up, and then I'm going to have you finish it in class. So we just need to write it out with the correct numbers. So there's your A, your B, and your C. And remember, the signs do matter. So x equals the opposite of b, so negative 0.84, plus or minus square root of 0.84 squared minus 4 times a times c, all over 2 times a. And I'm going to actually leave it at that for this video. We'll have more with the quadratic formula and more things having to do with solving these quadratic equations in the next video, and we'll talk about what we saw today in class. So make sure you copy this down right here, all of this, please, because we're going to go through and make sure we know how to do this on our calculator in class. All right, I'll see you guys in class.